Hey guys, George of SoundTraxx here, and continuing on with our what is DCC and how it works. Today we're going to talk a little bit about the programming track and how it can work for you. Now first off, let's just talk about what the programming track is. Now when we talk about our DCC systems, we have our main line, which is where we run our trains. Then we have the programming track, which is an isolated section of track that allows us to talk to the decoder in an isolated environment so that way we can communicate with that one decoder. So when we're talking to our decoder on the main line, remember our command is, hey everybody listen up, locomotive 589, move forward, speed step 10, turn on F0, turn on F1, end of transmission. But when you're on the programming track, now the command protocol is a little bit different in that the communication is not address dependent, and we're going to get into the differences and details here in just a second. Now, a lot of times this terminology kind of gets confusing because some people may have a second DCC system that's over on their desktop or their workbench that they use as their programming track, and then the layout is where they run their locomotives. And so this is why it's important to differentiate what I'm talking about when I'm talking about mainline versus programming track protocol. Now, when it comes to the operation on your programming track, there's no address to tell and identify which decoder it's talking to. And so that way, the language on the programming track is designed in such that any decoder following NMRA DCC will respond. So this is where we're allowed to be able to talk to a decoder to find out what its address is or to find out a CV value. Now, when you read a decoder on the programming track, it doesn't read it the way you think it does. In other words, the DCC system doesn't say, hey decoder, what's the value in CV8? And the decoder says 141. What it actually does is it plays a game of 256 questions. So going back to when we were kids and we played 20 questions, the answer is either yes or no. In this case, the question is, hey decoder, is the value of CV8 0? The next question is the value of CV8 255. Is the value 1, 2, 3, 4, 5, and so on, all the way up to 254. Now, when the decoder answers no to the question, nothing happens. The decoder just sits there and nothing happens. But when the decoder answers yes, the decoder is designed to draw a specific amount of current through the decoder, or in some cases through the motor circuit. And the DCC system on this isolated piece of track is able to detect that surge in current, interpreting that as a yes answer. Therefore, the question that's last asked in your command station is the value of CV8 141 now displays CV8 equals 141. That's it. There's nothing more sophisticated about it. It's very rudimentary and very simple. Now, this is how we can read and interrogate an address. So most DCC systems have a way on the programming track to interrogate the address. The other way is if you know the CVs, CV1 for the basic short address, or CV17 and 18 for the extended or long address, you can just read those CVs, jot those values down, and determine what the address is. Alternatively, you can overwrite the existing address in the decoder on your programming track and then pick it up, put it on your main line, and then now you know the address that's currently active. This is also good for troubleshooting. So if you have a decoder that is on your layout that is making noise and not responding to commands, that's a great place to bring it back to your programming track to interrogate and get the address. The other thing is if you have a decoder that's just not responding and not doing anything, you can take it and put it on your programming track. Try to read CV8. If it's a SoundTraxx product, it's going to come back at a value of 141, which is the identifier for SoundTraxx products. So the programming track becomes a very useful tool when trying to communicate with your decoder and trying to find out what's going on. And again, as a failsafe, if all else fails, you can always take your programming track, set your decoder on there, set CV8 to a value of 8, and when you pick it up and put it back on your mainline track, that constitutes a cycle in power, and so therefore your decoder will reset once power is restored. Now, when it comes to power supply on your programming track, back in the early days of NMRA, when they designed DCC, they didn't trust us to install decoders ourselves, and I mean us as modelers. And so what the idea was they set the programming track to about half power of what your typical mainline is going to be. The reason for that is because if something was cross-wired or if something was wired up and connected in the wrong place, you potentially are not likely going to damage the decoder like it would be as if it was a full power and full amperage. Now, where this came into play was more along the lines of the original Tsunami. The power that the processor needed on the original Tsunami was a little bit more than what most programming tracks offered. And so SoundTraxx offered a product called the PTB-100, or Programming Track Booster. And basically what this did is this amplified the signal on the programming track, so now that the Tsunami and other brand sound decoders can now reliably read and write now that they're giving full power. The good thing about our Programming Track Booster is it also does have that short circuit protection built in, so that if you do have something wired up, it's going to flash a red light at you and it's going to say, hey, stop, there's something wrong. Now, there are other brands of programming track boosters out there. Now, when you're using other brands, there are other brands of programming track boosters out there, but be careful with that because a lot of them require that higher current draw that a motor bump would actually draw during that acknowledgement process, whereas the Tsunami2 and the Econami, those acknowledgement pulses were taken off of the motor circuit because with over 800 CVs in the Tsunami2 alone, if it was to pulse every time you would read a CV, in example, a program like JMRI, the decoder the locomotive would move well off of the small little isolated programming track. The problem is that some of those other boosters now no longer allow the Tsunami2 to be read because it's looking for that higher current draw of the motor. So be careful when you're using those that you can remove them out of the circuit and work with the Tsunami2 and the Econami just fine. But if you want to leave it in there, your PTB-100 is going to be the best option. Now, once upon a time, there was a myth started about programming on the main line, and I hear it all the time. Clubs are outlawing programming on the main because they don't want you to accidentally reprogram everybody's decoder. Now, on the programming track, remember, the programming command is not address dependent, so any decoder that receives that command is going to follow. Now, where I believe that myth started is there's a lot of DCC systems out there, especially in the early days, that had only two outputs on the back of the connector for the track. And it relied on us to throw a toggle switch to route the power either to the main line or to the programming track. Well, if somebody goes into programming track mode and forgets to throw that switch, then the main line essentially becomes the programming track. So when I make my programming change, such as an address, and then I exit out, suddenly everybody's locomotives are reset because I forgot to throw that toggle switch. The power cab is another one of those, case in point. This power cab uses the same outputs for programming track or the mainline operation. So when I go in and try to set program use programming track, if I don't reroute that wire or if I don't use a different plug-in connector, then now my main line turns into a full powered programming track. So now any programming changes I will make will affect the entire layout. So this is something to keep in mind when you're setting up and using your programming track to make sure that you're talking to the locomotive that you're intending. And this is just a basic overview of programming track operations. Now, for more detailed information, be sure to check out our webinar series on our YouTube channel here in the link below to find out a little bit more about DCC, how it works, and including the programming track. Now, other references you can find are the DCC System Users Manual. Contact them if you have any questions on how to use their systems or which systems require which particular setups and how to boost or if boosters are even necessary on their programming tracks. And last, be sure to check out our user's guide for detailed information on programming and setting up the Tsunami2 equipped locomotives.